Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi everyone, welcome back to day 34 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from permutations and combinations and probability. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video useful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more such videos, subscribe to our channel. And without any further delay, let's get started with the first question. There are 6 boxes numbered 1, 2, so on till 6. Okay. Each box is to be filled up either with a red or a green ball in such a way that at least one box contains a green ball and the boxes containing green balls are consecutively numbered. The total number of ways in which this can be done is okay. So 1, 2, 3, 4, 5, 6. Now it is mentioned that there should be at least one box containing a green ball. Now let me consider there is exactly one box containing a green ball, right? Because at least one means exactly one, or it can be exactly two, or exactly three, so on till exactly six, right? Now exactly one. So green ball can be in box number one, or two, or three, or four, or five, or six. So there are six possibilities. Now exactly two. Now, if we have two boxes containing green balls, those two boxes should be consecutively numbered. So they can be 1, 2, or 2, 3, or 3, 4, or 4, 5, or 5, 6. So you have 5 possibilities. Now, if I consider exactly 3 green balls, so that could be 1, 2, 3, or 2, 3, 4, or 3, 4, 5, or 4, 5, 6. 4. Now, if I consider exactly 4, you'll be having 3 such cases. Exactly 5, you'll be having 2, and all 6 or exactly 6 you'll be having only one case, right? Now we should be finding the sum of all these numbers: 6 plus 5 plus 4 plus 3 plus 2 plus 1, 10, 10 plus 5, 15, 15 plus 6, 21. Hence option B should be the answer to this question. Now coming to the second question, chess game between A and B can end in either A winning or B winning or in a draw. The probability of A not losing is 4 by 5 and that of B not losing is 2 by 5. What is the probability of a draw? Right. So in this event we have three possibilities. You can have A winning or B winning or it could be a draw. Right. So the probability of A winning plus the probability of B winning plus draw should be equal to 1, right? The probability of A not losing is 4 by 5. Now what is the meaning of A not losing? Either you can have A winning or draw. Now this is given to be 4 by 5. And that of B not losing. What is the meaning of B not losing? You can have B winning or a draw. Now this is 2 by 5, right? Now let me add these two. So A winning plus B winning plus plus draw is equal to 4 by 5 plus 2 by 5, 6 by 5. Now we know that this is nothing but probability of occurrence of that event, which is 1. 1 plus probability of draw is equal to, 6 by 5, or the probability of a draw is 6 by 5 minus 1, 1 by 5. Hence option A should be the answer to this question. Now coming to the third question, how many natural numbers from 1 to 2000 have none of the digits repeated? So from 1 to 2000 you will be having some 1 digit numbers, 2 digit numbers, 3 digit numbers and some 4 digit numbers as well. Now coming to single digit numbers. So you have 9 single digit numbers from 1 to 9 without any repetition. So you have 9 numbers. Now coming to 2 digit numbers, right? Now, in a two-digit number, in any number, the leftmost digit cannot be 0. So this can take any value from 1 to 9. So you have 9 possible values. And now for the second digit, you can include 0, but you cannot include the digit that we had already placed in the first place, right? So you will be having 9 choices or 9 possible digits to place here. So 9 into 9, 81. So there will be 81 two-digit numbers without having those two digits same, right? coming to 3-digit number. Again, this cannot be 0. So 9. Now you can include 0. Again 9. And this should be 8. So 9 into 9. 81. 81 into 8. 648. Now coming to 4-digit numbers. Now these 4-digit numbers will be from 1000 to 2000. And in 2000 you have digits being repeated. You have 3 zeros. So we cannot consider 2000. So we'll be considering numbers from 1000 to 1999, right? So this should be 1 only, right? Now we can select this digit into in 9 ways, this in 8 ways, and this in 7 ways. Now 9 8 72, 72 into 7, 70 into 7 is 490, 2 into 7 is 14, so this should be 504, right? So 9 plus 81, 90, 90 plus 648, 738, 738 plus 504, 1242 should be the answer to this question. Now coming to the fourth question. Ananya owns two art boxes, box A and box B, containing a variety of unique pencils and crayons. The number of ways she can select two pencils from box A is 91. The number of ways she can select one pencil from each box is 532. The number of ways she can select one crayon from each box is 253. The number of ways she can select one pencil and one crayon from box A is 322. In how many ways can Ananya select any two tools, both pencils, both crayons, or one of each from the entire collection in both the boxes? Right. So here we have two boxes, A and B, containing crayons and pencils. Right. So crayons, pencils. The number of ways she can select two pencils from box A. Right. So if there are n pencils, so NC2. From n you are selecting 2. Now this is equal to 91. Now let me expand this. What is the value of NC2? N into n minus 1 by 2 factorial, which is 2, is equal to 91, or n into n minus 1 is equal to 182. Right. So n and n minus 1, two consecutive numbers. Now what are the two consecutive numbers whose product is 182? 14 into 13, right? So that means there are 14 pencils in box A, right? Next, the number of ways she can select one pencil from each box is 532. Now selecting one pencil from 14 pencils in 14 ways. Now let there be m pencils in box B, selecting one pencil from m pencils m ways. Now this is equal to 532. Now two sevens, 2, then 66. Now 7 ones, 7 threes, 8. Right. So there are 38 pencils in box B. Now the number of ways she can select one crayon from each box is 253. And the number of ways she can select one pencil and one crayon from box A is 322. Now let there be C crayons. Now from C crayons, if you are selecting one, that can be done in C ways, and one pencil from 14 pencils, 14 ways. Now this is given to be 322. Now two sevens, two ones, 61. Now this is 23. So you have 23 crayons in boxes, and it is also given that the number of ways she can select one crayon from each box is 253, right? So we are selecting one crayon from 23 crayons, that in 23 ways, and let this be x crayons in box B. From x you are selecting one x ways. Now this is 253, right? 11. So there are 11 crayons in box B, right? Now what was asked? In how many ways Ananya select any two tools? It can be both pencils, both crayons, or one of each from the entire collection in both the boxes. Now, how many tools are there in both the boxes? 23 plus 14, 37, 37 plus 11, 48, 48 plus 38, 86. Right. from 86 items, Ananya should be selecting 2. So 86 C2. So that would be 86 into 85 by 2. Now 43 into 85. That should be your answer to this question. Now coming to the last question, the number of ways of distributing 8 identical balls into 3 distinct boxes such that none of the boxes is empty is, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 8 identical balls, and we have 3 distinct boxes, and this be A, B, and C. Now none of the boxes should be empty, so there should be at least one ball in each box, right? So what I am doing is I'll be placing one ball each in all the 3 boxes, right? Now we need to place these 5 balls in these 3 boxes, right? Now let's see in how many ways can we do that. Now I can place all the 5 balls in any of these 3 boxes, right? And remaining 2 boxes having 0 balls, right? So 5 0 0, in how many ways can I arrange them? 3 factorial, by since you have 2 zeros being repeated, by 2 factorial, right? Now again I can write this as 4 1 0. Now since the 3 boxes are different, right, we need to arrange them in how many ways? 3 factorial ways, because all these 3 are distinct. So 3 factorial. So 5 हो गया, 4 हो गया. Now 3. Now this could be 3 2 0, all 3 distinct, 3 factorial, and I can also arrange them in 3 1 1 ways. So that would be 3 factorial, by since we have 2 ones, by 2 factorial. Now 2. Now this could be 2 2 and 1, right? So that will be 3 factorial by 2 factorial ways, right? Is there any other possibility? No, right? Okay. Now what is 3 factorial by 2 factorial? 3, 3 factorial 6, 3 factorial 6, 3 factorial by 2 factorial 3, 3 factorial by 2 factorial 3. So total 3 plus 6, 9, 9 plus 6, 15, 15 plus 6, 21. Hence option B should be the answer to this question. I know most of the students are scared of PNC because they had studied PNC as a subject of mathematics. But here we'll be dealing PNC as a subject of quantitative aptitude, right? So whenever you come across a question based on permutations and combinations, don't panic. Just first identify the logic, right? So logic समझना important है, and all the other things NCR, NPR, they'll fall in place, right? So first let's write down the steps. Now what is to be done, right? Then you can simply apply NCR or NPR once you know what is NCR and NPR, right? So identifying the logic is very important when dealing with a question based on permutations and combinations.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.